Welcome to Jeremy's IT Lab. This is a free, complete course for the CCNA 200-301. If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment, and share the video to help spread this free series of videos. Thanks for your help. Let's get started. In this lab, you'll practice and develop your understanding of some of the concepts learned in the Day 5 and Day 6 videos on Ethernet LAN switching. As you can see, the network topology we will use in this lab is like the example network I used in those previous lecture videos, with two switches, each with two PCs connected to them. Let's get started and go through the steps. First off, there is a note saying that both switches have an empty MAC address table, and all PCs have an empty ARP table. Keep that in mind as you try to answer step 1, which asks us, if PC1 pings to PC3, what messages will be sent over the network and which devices will receive them? So, if PC1 wants to send a ping to PC3, it has to know PC3's MAC address. We can type ping 192.168.1.3 on PC1 to send a ping, but until PC1 knows PC3's MAC address, it can't send the ping. That means PC1 will have to send an ARP request. So, that's the first message. Now, which devices will receive the ARP request? Well, the ARP request is a broadcast message, so all devices on the local network will receive it, except for PC1, of course, which sends the message. PC2 and PC4 will ignore the message, but then PC3 will send an ARP reply, which is the second message. Unlike the ARP request, which is a broadcast message, the ARP reply is a unicast message. So the message will be sent through switch 2 and switch 1, and then be received by PC1 only. No copies of the message will be sent to PC2 or PC4. Then, PC1 will be able to add PC3's MAC address to its ARP table, and use that information as the destination address of its ping. So, the third message that will be sent is an ICMP echo request from PC1. This is a unicast message that will be received by PC3 only. Then, PC3 will send an ICMP echo reply, which is also a unicast message that will be received by PC1 only, after passing through switch 2 and switch 1, of course. So that's it. Those are the messages that will be sent over the network if PC1 pings PC3. Now, there won't be just one ping. PC1 will send multiple pings, 4 by default from a Windows PC. Step 2 asks us to send the ping and use Packet Tracer's simulation mode to verify our answer. First, let me click on simulation mode here in the bottom right. Then, to send a ping from a PC in Packet Tracer, click on the PC, click on Desktop, and click on Command Prompt. Now just type in the command. PC3's IP address is 192.168.1.3, so the command is ping 192.168.1.3. Immediately, you can see that both an ICMP message, which is the ping, and an ARP message appear. I'll click on the ICMP message, and then click on layer 2. Look at the info here. The next hop address is a unicast. The ARP process looks it up in the ARP table, but the next hop IP address is not in the ARP table. The ARP process tries to send an ARP request for that IP address and buffers this packet. Buffers means it holds the packet, so it can send it later. Now let's click on the ARP message and look here at the information. This time I'll click on Outbound PDU Details, which shows us detailed information about the frame. Do you recognize these fields? Preamble, SFD, destination address, source address, type, data, which is the encapsulated packet, and then FCS. If you watched my last two videos, you should recognize all of these fields of the Ethernet header and trailer. Notice in particular the type field of 0806, which indicates ARP, and the destination MAC address of all Fs, which is the broadcast address. Okay, now I'll exit from here and click through the process. The ARP reaches switch 1, is broadcast to PC2 and switch 2, and then broadcast to PC3 and PC4. Only PC3 replies, this time with a unicast message which arrives at switch 2, then switch 1, and then PC1. PC1 can then, finally, send its ICMP echo request, which is unicast and goes to switch 1, switch 2, and then PC3. PC3 then sends the ICMP echo reply back through switch 2, switch 1, and then arriving at PC1. I'll just press this play button, and you can see the rest of the pings being sent between PC1 and PC3. There should be 4 in total, as these packet tracer PCs operate like Windows PCs. Cisco devices, however, send 5 pings by default. Now, step 3 tells us to generate network traffic and allow the switches to learn all MAC addresses of the PCs on the network. Remember, switches dynamically learn and enter MAC addresses into their MAC address table by looking at the source address field of frames they receive. So, since we just pinged between PC1 and PC3, both switches should know their MAC addresses. But just in case, I'll switch back to real-time mode and send one more ping from PC1 to PC3, because sometimes Packet Tracer has problems with simulation mode. Okay, next, let's send a ping from PC2 to PC4 so that the switches can learn their MAC addresses. I'll go on PC2. And now I'll ping PC4. Ping 192.168.1.4. Step 4 asks us to use show commands on the switches to identify the MAC address of each PC. Because the interface each PC is connected to is displayed on the network diagram, if we look for that interface in the MAC address table, we will be able to identify the MAC address of each PC. I'll go on switch 1. We have to be in privileged exec mode to view the MAC address table. So use the command enable, or just en. The command to view the MAC address table is show MAC space address hyphen table. Make sure you don't mix up the space and hyphen. Okay, first of all, let's find PC1, which is attached to the Fast Ethernet 01 interface. Here it is, and you can see the MAC address here. Note that the MAC address in your lab may be different. I'm not sure if Packet Tracer keeps the MAC addresses consistent if you load the labs up on another computer. How about PC2? Well, it's connected to Fast Ethernet 02, so here is PC2's MAC address. Now, as for PC3 and PC4, we have a problem. Switch 1 only knows that it can reach these two MAC addresses via Gigabit Ethernet 01. Just by looking at this MAC table, we don't know which address belongs to PC3 and which belongs to PC4. So let's go on to switch 2. Once again, I'll enter privileged exec mode, enable. Now let's view the MAC address table. Show MAC address table. PC3 is connected to Fast Ethernet 01, so this must be its MAC address. And PC4 is connected to Fast Ethernet 02, so this must be its MAC address. We have successfully used the show MAC address table command to identify the MAC address of each PC. Now let's do step 5, which is to clear the dynamic MAC addresses from the MAC address table of each switch. Since I'm already on switch 2, I'll start here. The command is clear MAC address table dynamic, but before I hit enter, I want to show you something. I'll use the question mark, which is also known as context-sensitive help. As you can see, it doesn't display any additional options here. If you remember from the Day 6 lecture video, when I did the demonstration in GNS3, I could clear specific MAC addresses by specifying the address or interface. Packet Tracer, however, does not support this option. You have to clear all MAC addresses. So I enter the command, then I'll use the up arrow on the keyboard to go back to the show MAC address table command. Enter it once more, and you can see the MAC address table is now empty. I'll do the same on switch 1. Clear MAC address table dynamic. Press the up arrow twice to go back to the show MAC address table command, hit enter, And there we go. The address table is now empty. We have successfully completed this lab. Thank you for watching. Please subscribe to the channel, like the video, leave a comment, and share the video with anyone else studying for the CCNA. If you want to leave a tip, check the links in the description. I'm also a Brave verified publisher and accept BAT or Basic Attention Token tips via the Brave browser. That's all for now.